Now, I know this is the session after lunch, so hopefully everyone is still feeling really energetic. And just to make sure that you're in the right session, this session is about running AI at petabyte scale using Azure Data Lake, right? And just in case you're not in the right session, the door is there and you can move on to your next session, right? So let's get started. My name is Wee Hyong, and it's really hard to pronounce Asian names, so most people call me Talk, like we talked today in a conference like this, so hopefully that helps you remember. And ignore the title. A title is but a name, and I've worn many hats in my career at Microsoft. So I started off on the SQL Server team as a developer, and then I moved on to program management. And about 3 years ago, just before data science and AI burst into the scene, I said, well, my interest was really into data mining back in school, and data science really seems a really interesting topic. And that's how I moved into a data science role about 3 years ago, not knowing, hey, AI today is going to be a big thing and it's very real, right, as we have seen in a lot of the keynotes. And my role today as a data scientist manager on the part of the data platform group, my role is actually very simple. Usually I get a mail from my boss, and he says, hey, there's a specific group or specific customer, and they have this problem with data. They need some advanced analytics, AI expertise. Go figure it out. That's essentially the mail. And I usually receive it at around midnight, and then the next day I might be flying off somewhere trying to figure it out, right? And this work on doing AI at petabyte scale was both from a product through perspective, things that you can do today after the session, but more importantly, it was also a call from my boss, and he said, well, we have a support organization, right? And the support organization today has been collecting huge amount of call logs data, right? And he said, well, go figure it out. Well, we have all these cognitive capabilities in a data asset, which we call the data lake. Go figure out how they can run this at scale and how we can help them get a product 360 view of all the Microsoft product, more specifically, all the data product in the Microsoft family, right? So this is how this project started. Now, before I dive into things, just to get a sense of what your interests are, how many of you would call yourself an AI expert in the room? Any hand? Okay. Now, how many of you are excited by AI and the possibilities that you see? Oh, wow. Awesome. Then this is the right session for you. Now, like you, I'm excited about AI, right? I'm not an AI expert, but whether it's looking at all the kinds of cool videos at conferences like this and various other conferences, you want to be part of the action, right? But more specifically, you say, hey, whatever role you are right now, whether you're a developer, whether you are a system administrator, or you play different roles in different stages of your career, you want to be part of this AI action, right? And me was the same, right? I'm part of this data team for the past 10 years, moving across different data products. And when I saw this AI happening, I said, hey, I must be part of this action. And anytime there's this kind of projects, I will always volunteer and go figure it out, right? And therefore, today, the talk is really about how we can leverage a lot of the skill sets that we already have as developers and being able to leverage AI, even though we might not know how to build a deep neural net, or we're trying to learn how to build a neural net. We know we're not there yet, but how can I take advantage of things that's already been pre-built and immediately deliver value in whatever role and capacity I am in the company today, right? So before we get into that, and knowing that everyone is excited about AI, but do not have a lot of knowledge about AI, this just give you a few of the examples of projects that we've been working on. So this is really a project by Microsoft Research Cambridge, right? And the ability to use AI to look through a lot of what we call the tomography scans or the CT scans, and being able to detect any of these images that are shown, whether cancer is there, right? And then being able to help the oncologists as well as the radiologists to be able to more efficiently detect cancer in patients. Now, this is a project called Inner Eye, and you can actually search for it on the web. This is just one example of how AI can change our life, right? Now, and moving on, there is also work around using AI for real-time ID check. And this is some of the work that we did with Uber a while back on trying to say, well, we have cognitive services. At the keynote yesterday, you have seen some of the capabilities of cognitive services. How can we leverage some of this face detection and identification capabilities of cognitive services to be able to verify the identity of the driver so that you feel safe when you're on one of these rides, in this case, an Uber ride. Oh, this is one of the work which is really interesting, which is work that we did with a company called eSmart in Europe. And essentially what they do is the following, right? They send drones across huge pieces of land just to inspect the utility poles. And all these drones are collecting images about the utility lines as well as the makeup of the utility lines. And the goal there was really to say, well, if we know that certain parts of this utility pole as well as the line or certain components on it is due for maintenance, or from a model perspective is remaining useful lifetime is really, really low, then we could start scheduling the right trip for the technicians to go to specific areas to service this line. Now, and it also turns out that because a lot of these utility lines and the infrastructure that it has are always in a lot of very difficult to reach regions, like mountains and so on and so forth, not just in Europe, in Asia, and in other parts of the world it's the same, you really want to make sure that the trip made by this technician is productive. And more importantly, in that vehicle that they have, when they are going up all this difficult to reach region, they have all the right equipment that they need, right? And this was also an effort on us using AI, for one, being able to detect all the objects on the utility pole and be able to figure out which are the power lines versus these are the components. And then being able to then look at the shape of the components and being able to detect that, hey, the remaining useful lifetime of this component is really 40%, and therefore maybe it's time to send a crew up if there's a lot of this happening in that specific area. So these are just examples of AI in action, and I can't do justice into showing you all possible cases of AI, but if you search for AI stories Microsoft, on the Microsoft website, you actually see more of this happening, right? And you know that something is no longer hype, but it's very real. So real that, it's not just a talk that we had at a conference like this, so real that the software that we're experiencing on a day-to-day basis is infused with AI. We know we have to do something about it, right? Now, then the next question is, why does AI matter to us as a developer community, right? So many of the applications that we build today deal with data, right? If you're in IT, you deal with data, right? And the point here is we look at all these exciting innovations happening in the AI space, and we say, well, we want to build an application that can take advantage of AI. Maybe I should build an application that consumes cognitive services. Or I know I have a lot of data in the organization, and I want to have an AI conversation with my management, with my immediate team. I need to get started somewhere, right? And therefore, AI is very real to us as a developer community, and not just something that only people in white coats or people with PhDs can do, right? We all, and hopefully all of us in this room, by the time you finish this session and you leave, you get a sense of things that you can action upon immediately as a developer, but more specifically as a developer that does AI. Now we call them an AI developer, right? And it also turns out that if you look across the major generators of data over the years, right? And this is projected storage of data up to 2025. If you start off with texture messaging from Twitter, right? You could easily do the stats. You get about 1.4 petabytes of data stored per year. Now, there must be some insights or nuggets of gold in all these 140 characters messages that if you can extract and you can enrich them, and finally being able to do something about it, and then let it be consumable by applications that you're building in whatever form, then the intelligence immediately becomes infused with intelligence, right? And then if you further go forward and you say, well, astronomy data today are images that they take of the sky, right? Projects like the Sloan Digital Sky Survey by Johns Hopkins and so on and so forth. Every single day, they are taking pictures of the sky, and they're sending this data through big data processing pipeline, right? And being able to extract what they call the photometric properties of these images, so that astronomers around the world can analyze the data and being able to make sense out of it. So much so that Professor Alex Zaley from Johns Hopkins University, whom we interacted with a while ago, told us that, well, the world's largest telescope is not really that physical telescope. The world's largest telescope is the computer systems that is processing all these astronomical images at astronomical scale, right? And being able to turn them and store them in some data store, if you will, and letting astronomers examine every part of the universe just from the applications they build, right? Now, and if you further move to the right, we started looking at video data, right? And here we gave YouTube as an example, but we know that it's not just about YouTube data. It's about all the video data that you're collecting, right? It could be data that you're collecting from surveillance cameras. It could be data that you're collecting from things that you film on a day-to-day basis. All this video data gets stored somewhere, right? And today, how can we analyze things in the video data at a scale where we can then start asking questions to say, hey, show me all the frames of the video, or show me the specific part of a video where someone uttered awesome, or someone uttered Microsoft Build Conference, or someone made a statement, or there was a presentation with a slide that shows certain text. How can you just do a select star and say, find me that video file that has it, and which particular part of the file, right, or which particular minute and second that frame appeared? That will actually allow a lot of us to scan through huge amount of data, whether it's image data, video data, or texture data, at a phenomenal speed, right? And today we're going to show how we can do that using the Azure Data Lake. Now, the last piece is really something that's really close to us as well, genomics, right? And genomics data is just going to grow at an exponential scale. And this is just a projection of 2 to 40 exabyte per year. And this is a very modest projection. And the point here I'm showing you this slide is the following. As long as we live in a world of data, whether it's data that's generated by the applications that you're building, right, or data that's generated by other sources, right, by us being able to process this at scale, or having an infrastructure to process this at scale, right, at phenomenal speed, using familiar skill set that we already have, will allow you to do more things than you can already do today, right? Now, let's switch gear a bit and we talk about, well, I showed you a lot of data, but you say, hey, you know, what has it got to do with me? Let's take a look at my data, or your organization's data. Now, today, in any organization on the planet today, you have data that's sitting in a database, or you have data that's sitting in a data warehouse, right? And at the same time, if you start owning a lot of the web assets, you have a lot of web logs, which are unstructured data or semi-structured data, right? And all this contain huge amount of information. API failure call, you know, what kind of pages people is getting, what is the kind of path they are following through your website. And at the same time, if you operate a call center, right, one of the things that we've been hearing a lot from customers is today, in any call center in the world today, you get a lot of call logs data. Now, this call logs data could be of two forms. One, it could be as you call in, for example, if you call Microsoft support, right, and we have some of our team in North Carolina, Charlotte, and then they'll ask you about, hey, you know, what is the symptom that you're experiencing, hopefully to help you get to a resolution, right? This call could span for several days if this is a call that is a more difficult infrastructure issue and so on and so forth. Now, all this gets captured as call logs, right, or support engineer logs. How can we analyze this just to get a sense of course, there's a lot of frustration in this kind of call logs, right? But how can we get a sense of what are the kind of key phrases people talk about? What is the sentiment that people have on a call as the call progresses? Now, today, this is not easily doable, right? And of course, you ask for, you know, surveys, you send mails to you send mails to the support engineer, asking you to rate the call. But a lot of these nuggets of information lie somewhere. It could be stored in a database, it could be stored in Azure Blob Storage, it could be stored in a data lake, right? Now, the other interesting thing that you might also have noticed is today, not just that when you call Microsoft, if you call any kinds of service kind of company, right? Remember, if you call, and of course, after you get through the press 1 for this, press 2 for that, and 3 for that, you get to a point where they will tell you, hey, you know, you're going to speak to a call representative. Would you mind if your call is recorded for training purpose? Sounds familiar, right? And all this, once it gets recorded, there's audio data that gets recorded. Now, there's rich set of information in those audio files that's amazing, right? For example, when I was doing my rotation as a program manager, one of the things that we're asked to spend a week with the call center people and we listen, and literally people might scream at you through the other line because, you know, there's a problem and it's a very high priority problem. You get to experience the call as it is, but how do you then analyze all this call log to say someone did uttered a particular statement about a particular product. And in another call, they also did the same thing. And maybe these are things that we should hand it over to both the product as well as the program managers as well as the engineering team so that they can do something to fix all this gap. So much so that today, we tell a lot of our program managers as well as our product managers to say, well, the secret to understanding a customer is not, yes, of course, meeting everyone at conferences like this is great, but it's to listen, right? To listen to what are your scenarios, to listen to what works, what does not work. This gives you huge amount of information to build the next big product that you want to build, right? Now, and of course, if you go extreme right, again, you have images and videos. Now, with all this data in the organization, how can you process them, right? So then we switch gear a bit. We say, well, if we have a hypothesis here, if the hypothesis here is that AI, or leveraging a lot of this computer vision, some of this speech to text, and all this technology that AI offers today, would allow you to do it, then one of the first conversations that you might have with AI or machine learning or data science practitioners is to do AI is really boils down to two really simple concepts, right? Whether it's traditional machine learning or whether it's all this AI deep learning conversation that you have been hearing throughout the conference, it's really about training a model, and those give you examples of the different kinds of models to train. Now, just as a show of hand, how many of you does those words mean anything to you, or it is gibberish, or? Okay, awesome. So that's great, right? And then, suppose you know all this, have you ever built your own decision tree before? Awesome, and you see the number of hands actually goes much lesser and lesser. And of course, if I go on and say, hey, have anyone in the room built, say, a convolution neural net or recurrent neural network, just to get a sense of hands? Anyone does that? Oh, awesome, right? But you'll see that the hands gets lesser and lesser. And the point here is, of course, we could do it, and this often is because you have specific use cases where you need custom models, and you start getting and training a body of people in your organization to be able to do that, right? Now, let's suppose you have a model. Hypothetically, let's suppose you have a model, and the model is awesome, and you are able to do what you need to do for your scenario. The next thing that most people would get into is to say, well, now I have a model, I have to figure out a way to operationalize one of these models. For example, right? Today we know something like a convolution neural net, which is kind of a form of deep nets, right, that has gained popularity since 2012, right? But it was invented much earlier. If you want to use it to be able to detect pictures of cats and dogs in your images, then you need to deploy this into some operational environment. It could be a web host via a web API, or it could be an infrastructure that you own, and you write code that wrap around the model. But the point here is you're able to hand new instances of your data to that model, and the model is going to return you, is it a cat, is it a dog, or in the case of, say, the eSmart utility inspection, is that a component on a utility pole, right? And therefore, being able to score model at an infinite scale is amazing because many of the times you're not doing this kind of request-response kind of model, right? Unless you're building a mobile app where you say, hey, if I take a picture of something, I want an immediate response, right? But if you have millions of images or petabytes, or not even petabytes, terabytes of images, how do you do this scoring at an infinite scale using models that has already been built, right? So this is what we're going to explore today. So then the next question is, we said, well, we could have people that knows how to build the models, but many of us doesn't know how to build the model. And we said, well, I want to build or develop an AI application. How should I get started? Well, as I said, for some of you that know some of those terms on the screen, you could train or create your new model. And today, the Azure infrastructure provides you with a lot of capabilities to do that, right, on even clusters of GPU machines. And of course, you could do that. But many of us would say, well, we want to leverage AI APIs. Cognitive services is an example of AI APIs, right, that allows you to do things from text to speech, speech to text, being able to do computer vision, being able to detect landmarks in pictures, being able to extract key phrases, or even understanding the sentiments of some text, right? You could do it, and of course, most of these AI APIs today that's out there, many of them are REST API, and therefore, regardless of any kinds of development languages that you know, whether it's Java, whether it's .NET, whether it is Node.js, and so on and so forth, you could develop application as long as your language speed rests, right? And of course, the third thing here is, which you have seen some of the sessions yesterday, if you have been to some of the data session that we've been talking a lot about, is you have data sitting somewhere. Your data could be in a database. Your data could be in a data lake. And your data can be anywhere. And if you really want to do AI at petabyte scale, right, or terabyte scale, or whatever scale that you desire, you need to get to a point where you can bring all this AI to where the data is instead of trying to do data movement, because data movement is very expensive, right? And how can we do it? So today, the focus of this session is really on the two parts, using some of these AI APIs, right? But using some of these AI APIs or similar functionality where the data is, using something called the Azure Data Lake. Now, so to start off, let's start off with using APIs. Now, you have seen a lot of these cognitive services already, and let me just show you some of them just to orientate you. So today, you will see that if you go Microsoft Azure and you search for cognitive services, you see a bunch of APIs. So for example, today I could say I click browse, and I could say, well, let me give it an image. So I could give an image of a family. Now at this point, that image gets uploaded to the cloud, right? And the cloud, the API then does analysis of the images, and they start detecting, hey, you know, for this face, this is where the face is, and for this face, we really see certain scores like anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. And if you go further down, it tells you where each of the face rectangles are. So today, in fact, you have seen a lot of innovative apps just using out-of-the-box AI API like this, right? And for some of you that have been to the previous build, one of the things that went viral overnight was this site. Does this look familiar to you guys? Right? And this went viral beyond our wildest imagination. We built this as a demo app at one of the earlier builds, not knowing that, hey, you know, everyone is going to access it, including people outside of the United States, in areas that we have not even imagined, right? And the reason why this is able to scale at that amazing scale is because all this is built on web infrastructure, and we, underneath the hood, is able to elastically scale all this capacity to meet the needs of that viral app that you saw earlier, right? Now, and of course, today, if you go further down, there are other very interesting APIs. So if I were to click, let me just close one of this, computer vision. I have APIs that does the following, right? And some of these are really new. While this is loading, I already pre-opened this. I could upload pictures of text, right? This could be machine-printed text. It could be handwritten text. And then I'm able to do OCR on top of it. Now, why is this important? Because it turns out that in a lot of the customer conversations that we have, many people have annual reports, or there's organizations that build their business all around being able to analyze annual reports for all the publicly listed companies, and being able to then extract out insights in this annual report that might give them that competitive edge, right, in whatever kinds of financial investment that they're looking at. And therefore, how do you then say, hey, you know, take all these annual reports and then being able to analyze this at an infinite scale? You must have the right infrastructure to do it, right? There's two ways of doing it. One, you build your own infrastructure, which takes a while for you to have the right architecture. Or you dump all these images into an infinite scale store like Azure Data Lake, and then being able to leverage the same cognitive capabilities that you see here on those things running on clusters of machine, and this is what I'm going to show you in a while. Now, this also turns out to be a very interesting use case for a lot of financial institutions and healthcare, even telcos, where it turns out that for some of these organizations, they've been printing out bills and sending the bills as PDF files, of course, the printed PDF files, to customers, right? And then it turns out that over the years, whatever information that was used to generate the bill are gone. And now all they have is the bill and the PDF files. And now they want to reverse engineer this and turn the PDF right, of the bills and whatever that they have in the organization back into text so that they can start answering questions. Again, you need to do this on an infrastructure that you can scale up and down depending on your needs, right? So today, we're not going to show you cognitive services because the session before this, and some of you might have attended Anna's session, and she helped drove some of the traffic here. She already shown you enough of the cognitive services example. At the booth, as well as the Microsoft Hub, you should also find people being able to talk to you about cognitive services. Now, today, what I'm going to show you is really take a lot of this cognitive capability, not all of them, and we're still catching up, and being able to do this where the data is, and in this case, in the Azure Data Lake, right? Now, just a show of hand, anyone have seen Data Lake or have heard of the term Data Lake or have seen Azure Data Lake? Azure Data Lake? Awesome, okay. Now, and how many know that Azure Data Lake has inbuilt cognitive capabilities? Awesome, right. So for those that have seen, please be patient with me. I'll show you other stuff that you might not have seen from the public examples. And for those that have not, hopefully this will give you a sense of how we can use Data Lake to do all of this. Right? Now, and therefore, this really leads us to this piece, right? What if you have gigabytes, terabytes, and petabytes of data? Now, just a show of hand, how many of you work with gigabytes of data on a day-to-day basis? Petabytes? Oh, wow. Sorry, I didn't go the right order, and terabytes. Awesome. So today, we know that terabyte, gigabyte is no longer something imaginary or science fiction, right? It's very real, right? And Azure Data Lake offers you a lot of good capabilities for you to store this data and process them. And Azure Data Lake today is really two pieces. One is the Data Lake Store, where you could dump both structured and unstructured data, including images and videos, into Data Lake Store, right? And then there is another piece which we call Data Lake Analytics, which then allows you to run jobs, right, at an infinite scale, and the scale is really determined by you, right? And therefore, for those that have not seen Data Lake before, we'll quickly go through creation of a data lake just to walk you through what it looks like. Now, what you see here was one of the petabyte scale data lake that we prepared for this demo. And trust me, even though some of you have worked with petabyte data before, getting a data lake up to petabyte size is a really fun experience. If you have not done it, you should try it, right? Now, but we're not going. This is not about how we created this petabyte data lake, right? Now, what is inside this petabyte data lake? And just before I create the data lake, so if I drill down into the data lake store, and let's take a look at what are all the data that's sitting in this data lake now. Come on. Right, and if I click Data Explorer, you'll see that in this data lake, we have huge amount of information, but one of this set of data that we have that got it to petabyte size is really the support data. I'm going to show it to you in a while. Come on. So if I were to open Build 2017, let me find the right folder. Sorry, this is the wrong one. Let me show you the other one that I already have it prepared. Let me go to MS Build ADLS. And if I look at this, you'll see that I have in the data lake, it's just like any file system. And in fact, it has a web HDFS head. So if you have any HDFS client, you can just talk to your data lake. Now let's take a look at what is it in this data lake, right? Come on. Right, and if I go all the way down and I look at my support calls or AI immersion, you'll see that the support call, and this is just one example of the support call log. Let me just format the first row as header. Now, these data are not like rocket science, right? The schema of the data is really simple. We have a column that says which product the call is for. We have one which we call the service request number, and in this case, this is numbers that anytime, the first time you initiate the call for a specific problem, underneath the hood will create a specific unique service request number for you. This is a node ID, and this is just a running number or sequential number that we keep increasing. This is when the node is created, and this is the text. Now, and of course, the support engineers at Microsoft, right, uses tools to be able to key in all of this, and eventually all this gets logged. And we build back-end data pipeline to eventually ingest this into the Azure Data Lake. Now, we have about 10 years of data here. Right, and if you look at this, we have support core 15 terabytes. And if we keep drilling down into it, each one of this is further broken down into more of that same kind of files. Right? And all in all, the support core logs that we have from the core engineers, as well as social data that we've been ingesting, right? As well as all the service telemetry for all the Azure-based services that we have, as well as all the data points that we're getting from all the on-premises product that you're having. All this, all in all, we ingest all this raw data into the data lake. Sometimes after we do this ingestion, there are business questions that we know what we want to ask, but there are questions that we might not even know at that point in time. Right? But we want to have the confidence that all this raw data, or this raw signal, if you will, is sitting in a store like this, so that one day if I need to ask questions, or my management asks me for additional kind of questions, or repivoting of the data, I have the confidence that I can run a script on this data, and then being able to get the results back really quickly, without me worrying, oh wow, does my machine have sufficient RAM to deal with all this data? Right? So this orientates you to the data that we have in the data lake. Now, at the same time, in another data lake that we have prepared, we have also stored other kinds of data in preparation for the other demos that I'm going to show you today, but I'm just going to walk you through since we're in the Azure portal. So we have also prepared data that looks like this. Right, so if I go build 2017 day 2, I look at the scan images. I have ingested a few images that looks like this. And I'm going to show you what they are. Right? So the later part of the demo is we're going to start off with the support core data that I was showing you earlier and telling you what we can do with it using Azure Data Lake, right, running it on the petabyte set of support core data. And then we're going to move on from text to be able to process images. In this case, these images that you see here are really images that are extracted out from a project called Project Gutenberg. Right? So if we go to Mark Twain, these are really paragraphs that looks like this. It could be pictures, there could be some text below, or it could be a full paragraph. Right, like this. And we are going to use Azure Data Lake to be able to extract all this by performing OCR at scale, and then bringing this out so that we can analyze them. So that's the second piece of demo I'm going to show you. Now, the last piece of demo, which I'll show you in a while, was I was telling you about the story of the annual report. So one of the annual reports that we brought in, or letters from some of the big companies, is this one from the Bill and Melinda Foundation, a recent letter that they wrote about elimination of polio and the magic number that they want to reach. So we have ingested all these images into the Azure Data Lake. And next, we're going to analyze this as though it's just any texture data that we already have. Right? So we're going to start off with the support core data. Now, so let's take a look at what we can do with this data. So to do this, I'm going to switch here. And what you see here is a very familiar environment that every one of us are used to, Visual Studio. But more importantly, this is Visual Studio with Data Lake tools that I have installed. Right? And once you have Data Lake tools, as well as your Cloud Explorer, on the left-hand side of this, you will then be able to look at all your Data Lake accounts, right, and the store. And of course, you could use this to look at data that's inside your Data Lake store, or the Data Lake jobs that you have run, right? Now, the other part that you see here in the center is really one of the premise for us for building the Azure Data Lake as well as the Data Lake store and analytics is the following. We want to make sure that every one of us, right, as long as we know SQL, meaning how to write SQL statement against a relational database, we know USQL. And the language that you're seeing here today is really USQL, right? And this is just an example with no AI involved, where I say, well, I have data, and this data is coming from a table. Look at the terminology that's used. In Data Lake, you could create a table, right, against the data that's in the Data Lake store. And here what I'm doing is just very simple things like getting the distinct product count, the distinct service request, and so on and so forth. And once I'm done, I will output this result into a tally, right? And this is just a very simple example to illustrate that you don't need much ramp up in order to understand USQL, right? And of course, I could submit the job. If I've installed Data Lake tools for Visual Studio, I could actually run it as a local job if I'm not connected to the web, right? Or in this case, I could run this against my USQL team demo. And when I submit, this Visual Studio will then submit the job request together with the set of USQL code to ADLA, which is Azure Data Lake Analytics, and this is going to be processed at a scale that you desire, right? And of course, once I submit this, I could also say, well, I do not want to submit this using the basic unit. So in this case, you see here, we have this concept called parallelism. And here, of course, if you start off with 1, there's less compute thrown at processing your data. And therefore, if you're going to do this at petabyte scale, you really sometimes want to max up your parallelism, right? And therefore, we'll start allocating different set of compute resources on partitions of your data, which we're going to see in a while, right? Now, if I were to submit this job, once the job gets submitted, it runs in the cloud, but at the same time, it will create what we call a job view. So for many of you that might have worked with some of the big data tools and so on and so forth, and you say, well, I have a huge amount of data. It could be petabytes, it could be terabytes sitting somewhere, right? And of course, there's a lot of big data tools that's out there. But one of the problems with a lot of these big data tools is that when you run, it becomes like a black box. And if something does fail, you want to know how many bytes was read, how many bytes was written, and so on and so forth. It's very hard for you to, 1, debug. 2, what if you just want to leave the job running because it's a huge job, and a petabyte scale job is not going to run in a few minutes, right? I'm not trying to kid everyone, right? A petabyte scale job is going to run for hours. And when you come back, if something does go wrong, you want the ability to be able to then replay the job. So for example, in this case, I'm going to load the profile for a job that I ran earlier. And once I replay the job, I get a sense of what each stage of processing is there. Similar to many of us that has a SQL background, you look at the query plan. This is the query plan for your USQL jobs, right? Now, and of course, once this is done, you could hover on top, and you can get more interesting statistics about how much data gets read and written, right? So using Visual Studio and Data Lake tools, this actually gives you very powerful ways of looking into the insights of your job. And if you're going to do AI inside the data lake, this also gives you insights into what each stage is failing. We're not going to say that all jobs are perfect and it's going to run the first time you run it. You want to be able to debug it, and this gives you a great way of you doing it, right? Now, so earlier on, the job was running. I've submitted it. The job graph is constructing. I'm going to close this. Now, then the next question that we want to talk about was, well, this session is really about doing AI on the Azure Data Lake. So we're going to expand this, and now I'm going to show you, again, I'm going to use a database called support calls, and database is just a concept in the data lakes, right, which is just a grouping of related elements. In this case, it could be tables, and it could be data in the table, but all the data are stored on the Azure Data Lake store. Now, one of the things that you'll see here is I will have to load user-defined assemblies. And this assemblies is really the magic that allows you to do cognitive capabilities inside the Azure Data Lake. Now, by default, if I were to right now create an Azure Data Lake, right, let me try to create an Azure Data Lake, and I say Data Lake Analytics. And I say Data Lake Analytics, and I assume I already have a store. And when I create it, it's going to say web subscription. I'm just going to put this into one of my subscriptions. Let's say the demo subscription. And I'm just going to say this is build 2017 AI Lake. Right. I'm going to use an existing group. Let me just put this as a temp project. Let me see whether I have a good build 2017 demos. This is good Data Lake store. I might already have some Data Lake store that's there. If not, I'm going to create a new one. Right, there's a bunch of Data Lake store that I can use. I'll probably just use the Build 2017 Data Lake. Right? And this is how you go about creating a Data Lake analytic account if you have not done it. Right? Now, after you've done all this creation, I'm not going to wait for one to be created. If I go back to my main page, you will have a Data Lake store. In this case, I have an account called Data Lake Analytics. Right? What I'm going to do next is I'm going to click on this. And I'm going to start installing the cognitive capabilities. Now, where do you find the cognitive capabilities? If you go all the way down and you choose sample scripts, you're going to see two things. One, it says, well, copy sample data. Two, it says, install USQL extensions. Now, if I were to click install USQL extension, they say, are you sure you're going to install USQL extension to your account? If I click OK at this point in time, what is happening right now while it's copying the USQL extension files is it's taking all the DLLs that are used, the same DLLs that are used by cognitive services. Right? We're going to take all this DLL and put them into your subscription, therefore giving you image capabilities, giving you text analysis capabilities, and sometime yesterday, if you go and replay back the AI Harry Sham's keynote, you'll see Cornelia on stage showing you Data Lake doing landmark capabilities. Those are not shipped, have not shipped yet. Right? But as over time, we'll get more and more of these cognitive capabilities into the Azure Data Lake so that you can do this processing close to your data. Right? Now, while that was copying, what happened if when this has already copied? Right? So if I were to go and explore my data lake, and here I've already created some of this, and if I go Data Explorer, and I look at USQL ML, which is one of the database I've created, and I look at the assemblies, you'll see that here, any assemblies that I'm going to use in the demo later on have already been laid down onto your account. Right? And for those that's familiar with SQL Server, similar to the concept of assemblies in SQL Server, we have registered this into a database that you can use. Right? Now, then a lot of you might ask, what does it really mean to have an assembly? Right? And therefore, if I were to look at the storage in its raw form without that database abstraction on top of it, right, you'll see that here, I go to USQL extension. Let me just show you, and so that this is bigger. And if I click on assemblies, which is a folder, you'll see that what have we laid down? We have laid down extension for running Python code. We have laid down extension for running R code, right? And we have laid down other kinds of extensions that allows you to invoke .NET libraries and so on and so forth, right? And therefore, these extensions are nothing but DLL files that has been laid down into your account. And when we submit a job, which we're going to submit a job later, right, as we run, we will take care of moving the right DLL to the right compute node so that you can process it close to your data, right? So this just shows you how you get all these cognitive capabilities. And then all you need in your USQL code is just to reference the assembly, text sentiment analysis, text key phrase, split applier. And the rest of the code looks really simple, right? It says, process the data that's sitting in this core engineer logs of the schema I showed you earlier, produce, right, and schematize it such that it has product, node created on, but I also want to extract out the key phrase. How do I do it? All I need is to say, use machine learning text key phrase extractor, and underneath the hood, when Azure Data Lake Analytics receive this, magic just happens, right? It takes the DLL, it loads it. If certain compute node doesn't have it, it moves it for you automatically, and it starts processing the data for you on the petabytes of data, right, in parallel. Meaning if you have 1,000 files, million files, right, and if they are all partitioned, then it's going to assign several compute nodes on a section of the file, and later on it will take care of merging the results for you. Now, the other things that you'll see here as well, key phrase extraction seems simple. What about sentiment analysis? So in this case, I could then say, well, given the text that I have, the support engineer text that I have, let me run a sentiment analyzer. And that's it. That was the only line you need to add in order to be able to do sentiment analysis on the data that's in the data lake. Now, that is really powerful because once you have done this processing, this job or this uSQL job can be scheduled to run overnight. And if you're building application on top of this, your scheduled pipeline, which I'm not showing in today's session, could be running the uSQL job, getting the file produced, laying down the results into Azure Data Lake. And today, any file in Azure Data Lake store, you could easily use SQL Data Warehouse to connect to it, even without moving the data, if you choose to, or from a performance perspective, or if you want to be able to have a cache version in your database, you could run a job that goes to the Data Lake store, brings it out, put it into a database so that your application can access it. There's different modes that you can explore. But the point here is the hard part about cooking the data is already done in the Data Lake. Right? The AI that you can apply on it, and right now we're just seeing really simple text analysis, is already done out of the box without you having to worry, what DLL should I be copying and stuff like that. All taken care for you by the Azure Data Lake. Right? And once all this is done, of course, this is great, and I could again submit the job, which I'm not going to do it. Now, the next thing I wanted to show you is if this had been not a developer community, and if this had been a community that is like a UseR community or a Strata data conference or AI conference, then a lot of the data scientists as well as the AI technologists in the room would ask me this question. They say, well, you gave us cognitive capabilities. This has the same capabilities as per the cognitive services that you see when you use it for your application request response kind of pattern. But what if I, as a data scientist, want to write R code? What if I want to run Python code, right? Because we don't want things that you have given us. We want to run the code, and we want to train the model for some of you that already know how to build a model. And being able to use Data Lake as a way to score against, right, huge amount of data and leveraging the compute infrastructure. Then in this case, if you know R, right, all you need is glue that wraps around it to say, well, this is how the data should be shaped. But then, at the end of the day, all you need is then say, well, I want to process this using an R script. In this case, this is trying to predict the support call volume for the next 3 months. Now, whatever piece of code that's in here, which I'm going to show you in a while, there's no special things inside the R code, right? The R code was simply R code, right? R code that you'll write outside of the Data Lake environment. And in this case, I'm just doing a really simple time series forecasting using an algorithm called ARIMA, right? And once I submit the job, which is this job that I saw earlier, Data Lake Analytics is again taking care of copying the R script that you call to the respective nodes, acting on partitions of data, and then collecting the results and merging the results. Super powerful. Now, so let's switch gear a bit, and we say that it's not just about the text analytics, right? What if I want to be able to look at images? So in this case, there are images that we have ingested into the Azure Data Lake, right, stored in this database called uSQL ML. Now, how can you store it in Data Lake? There's 2 ways of doing it. One, if I show you what uSQL ML looks like, and I look at the table, and I look at this table, let's see, what is this table called? It is called Mega Face. Now, if I look at the Mega Face table, you will see the schema for this was we have a file name, and we have also stored the image data as a binary or an array of bytes inside the data lake. That's one way for you to store data inside. Or I could store the data and not take the byte. I could store the data directly into a folder, in this case, scan images, individual JPEG files. Both will work. It really depends on what kind of scenarios and requirements that you have. Now that you have done all this, I could then say, well, process data that's in the Mega Face table, but in this case, instead of me trying to do sentiment analysis, key phrase extraction, all I did was to add this line, says Microsoft Machine Learning, image tagging. Remember earlier on I was showing you cognitive services, and I upload a picture, and it shows you all the rectangles. Now this image tagging is then going to look at each of this image. In this case, these are data that comes from Project Gutenberg that I showed you earlier, right? And it's going to extract this out, and then it's going to put it somewhere, right? And here, for some of them that has human faces, right, all I did was to say, look at all the faces in the images stored on the data lake, right? and then being able to say, hey, how many of them, what are their emotions, whether people are angry, people are surprised, and so on and so forth. And again, I operate over partitions of the data, and I say I partition it by the file name so that I can do parallel processing. And in each of the partition, I put 1,000 files. Now, I could continue going on that once I've done all these interesting things, I could start saying, hey, for all those pictures that have tag that contain dogs and cats, I can then join them with the emotion that I'm getting from the humans that I'm seeing in the picture, so that I can know how many of these people having cats and dogs are happy people, or how many of them look surprised. And you will be surprised that if you go to the internet, which I did before this talk, right? Let me just show you. This kind of photos are really, really common, right? So if I go to here and go breakout and look at images, this kind of photos are really, really common, right? People taking pictures with their family cat, a kid holding a cat, a dog by itself, and I do that all the time. Like my son goes to a barn every Saturday, and they have really nice dogs there. Every Saturday for the same dog, I'm taking the same picture, which is really fun. But we do all that, right? And it's fun. And therefore, what that uSQL script that I have showed you was simply looking through all these pictures that we have stored into the data lake, and then it's trying to do a join, right? Something that you will never have done if you have no such infrastructure to say, look at all the pictures, extract, do tagging on it, and for all the text that get written, some of them will have cats and dogs in it. Then look at the humans in the picture, look at the emotions on their face, and then I join this, right, with that to be able to say, find me anything that has a cat and dog in it, what is the kind of emotion that the human is having, right? And of course, I output all of this data, and I could then submit this job and run this at a maximum unit at 200. And now Data Lake is truly going through all these phases and doing that for you. And the end result of this looks something like this, right? If I go on and I look at build 2017, I have emotion summary, emotion tag. You'll see that one column after I do the join has happiness, and it was a dog in the photo, right? And therefore, I can start doing interesting query. Now, at this point, some of you might be smiling at me and say, hey, there's no business enterprise value from analyzing cats and dogs and the emotion. So we're going to switch gear a bit, and we say, let's do something useful from an enterprise so that after the build conference like this, and we go back to our office, and we write our trip report. Your trip report is not about cats and dogs and emotions, right? Your trip report is about practical things that you can immediately bring value to your business. And therefore, we're going to analyze instead of cats and dogs, and I'm going to leave this job running, right? We're going to analyze content, right? So in this case, I'm going to perform OCR on annual reports. So you realize that now that you know the flow of uSQL, it's really simple. I say take all the images in the folder called annual reports, all the JPEG file, make use of the computer vision image extractor, and do OCR on those images. The text, let me put into the OCR text, right? And once this is done, let me replace all the /r/n so that I see it as one flat line. And I output this data into annual report 05. And the other thing that's very useful is not only can I extract out and do image to text using OCR, I can extract out key phrases in this annual report. And sometimes those are really useful nuggets of information for you to know what is inside the annual reports. And all I did again was the same flow, but using a key phrase extractor on the text data that I derived earlier, and also outputting it into annual report key phrase.csv. Now let me just run this as well. Now while this is running, let me show you the final results of it. Now if you go here, I have one which is the annual report. So this is looking through, I just posted 2 reports, right? These are the 2 reports I posted in Azure Data Lake. One is called the Warren letter. So this was the letter that Warren Buffett wrote to Bill and Melinda, right? This has also been copied into the Azure Data Lake. And the other one was really the Berkshire report from one of their recent conference, which looks really like an annual report. And right now, the job that I've submitted is actually looking through all of this in the data lake, and then doing OCR, and then doing key phrase extraction. Now, the final result of this, you see this. This was from the Berkshire report, and you get things like management, discussion, analysis of financial conditions, and so on and so forth. This was from the Warren letter, Dear Bill and Melinda. Right? All this was doing OCR. Right? And of course, for time purposes, I only had 3. This was from the magic number. But because I have the other segment of it that extracted out the key phrase, at a glance, I immediately know for each of these annual report or letters to shareholders, I'm immediately able to see what are the key phrases being uttered. So let's take a look. Now, while the jobs are still running, hopefully it has not resetted the file. Right, you'll see immediately, for those that is too small, in the Berkshire report, he is talking a lot about manufacturing business, high earnings, tax investment, retail business. Magic number was talking about polio. That was what the report was about, or the letter is about. Warren letter was talking about children, Berkshire's, occasion, years, writing, son, and so on and so forth. Right. So this shows you immediately, for all those annual reports, the bill that you want to extract, you can immediately use Azure Data Lake to do this, and back in your cubicle, and you write all this down, and a few hours later, you get back to your boss, oh, look, these volumes of annual reports, I have already processed them. Right? And you're not going to tell them that you're using cognitive in Azure Data Lake. You say, I've done a really hard job by typing it out, and this is your end report. Right? This gives you tremendous value, but joke aside, right? Being able to do this, being able to join this against other kinds of data sources that you have, give you tremendous insight. And one example of this was what we started off with, right? We have customer support call, and I really want to know, for a specific product like Azure Data Factory, what was the sentiment over time, right? And what is the forecast of call volume over the next few months? I can then use Power BI reports like this. Where does the data come from? This data comes from Azure Data Lake. And all I did here was simply clicking Get Data. Let me just new. Right. And then today, using Power BI, I can connect immediately to Azure Data Lake, getting one of the files that's processed. So if I were to do Get Data, more, and I look at Azure, I can immediately say, hey, let me connect to Azure Data Lake Store. And when I connect to it, all it does, and it asks me, is a URL. URL to files in the data lake that I have already, for a file that I've already processed. How did I get the file? If I go to the Azure Data Lake Store and I look at a file like this, and I look at properties, immediately you see the path here. All I did was copy and paste. And now, not only have I processed data at an infinite scale, I'm able to leverage a BI tool like Power BI to suck the data out. And then you get an example of a simple BI application. You could also connect to this directly using the applications that you're building, right? And today, Azure Data Lake Store supports 2 kinds of authentication. One is what we call user credential, using the OAuth flow. The other one is using a service principal, right? And if you use any one of these, you can get data out from the data lake, and immediately your application can access all these insights for all this AI that's running in the Azure Data Lake. Super powerful, right? So with this, to be mindful of time, let's just take a look at what we have covered today. Right, so we went on and we created the data lake. What we have shown you today was really this piece, which I highlighted in red. Using Azure Data Lake to be able to do cognition capabilities. But today, Azure Data Lake need not only just deal with data in the data lake. If you have an Azure SQL database, you can actually use federated query to, say, do a join in Azure Data Lake by bringing in reference data from your Azure SQL database, right? And the setup is really very, very simple. And therefore, not only can you work with petabytes of data, you can bring in data from a lot of your familiar data sources. And the last piece of it, which we did not cover, is being able to consume this using a technology called Polybase over Azure Data Lake Store to be able to do an external table against data in the data lake. And now you can build cubes on top of it. This shows you the end-to-end flow if I were to build this end-to-end, right? And of course, the goal of this was really simple, getting a 360 view of the product so that we build better products. Now, big cognition, we covered some of this, so you can download the slides after this. Use SQL extension, I've showed you, and you can do R and Python. Right, this is how it looks like, and I showed you a while ago. 3 steps, really simple. Install your use SQL extension if you have not done it. That will give you cognitive R Python capability. write your use SQL code. If you know SQL today, you know use SQL. Submit the job, and let the Petabyte Scale store take care of everything else, right? We saw this. This is just some examples so that you can refer to it after the talk. Examples for R code. Recap, you have seen all of this. And with this, thank you. Thanks a lot for your patience and time sitting throughout this talk. And hopefully this is useful to you, right? And you get a sense of what Azure Data Lake is, but more importantly, how you run AI at Petabyte Scale in Azure Data Lake. These are some of the sample codes as well as some of the resources that you can use. Thanks a lot, everyone. Thanks a lot, and have a great session.